Okay, this is from section 2.5 in the AP Calculus textbook on implicit differentiation. This first one I have is a product, so I have to do a product rule. So what I'm going to do is I'll bring one of them down, the x, times the derivative of e to the y. The derivative of e to a power is e to the same power times the derivative of the power. Because it's a y, I put dy dx. Plus the other way around, bring down the e to the y, times the derivative of x, which is just dx dx, which does turn into a 1. But all of this is a product rule, u times v. It would be u v prime plus v u prime. So far, this thing is x e to the y dy dx plus e to the y. Now, what's the derivative of 10x? Well, the 10 comes down, and the derivative of x is dx dx. So that just means minus 10. Plus the derivative of 3y. So I keep the 3. What's the derivative of y? Since it's a y, you put dy dx. Basically, if you take the derivative of x, you put dx dx. If you take the derivative of y, you put dy dx. At this point, you have 4 terms. 2 of them have dy dx. 2 of them do not have dy dx. We need to group all the ones with dy dx on one side of the equal sign and all the ones without the dy dx on the other side. So if you don't mind, I'm probably going to add 10 and subtract e to the y. What would that leave me on the left? Well, it would leave me with an x e to the y dy dx plus 3 dy dx. And now it's not equaling 0. Now it's equaling 10 minus e to the y. Many times in these, you have to factor out what you want to solve for. Both of these contain dy dx. So I'm going to factor out the dy dx, leaving me x e to the y plus 3. Now this equals 10 minus e to the y. The opposite of multiplying would be to divide. So you have dy dx equals 10 minus e to the y over x e to the y plus 3. Okay, I was also asked some other ones. I'm going to try and do them in a order of sorts. So I think 11 would be the next biggest one. Okay, the derivative of both sides. The derivative of sine is cosine of the same angle times the derivative of the angle. Because it's an x, I put dx dx. Plus 2 is a constant factor. I keep it out front. Derivative of cosine is negative sine of the same angle times the derivative of the angle. The derivative of 2y is 2 times the derivative of y dy dx. And then the derivative of this constant over here would be 0. So far I think I have that. Minus 2 times 2 is 4. Sine 2y dy dx equals 0. We have to get all the terms with dy dx on one side and all the terms without dy dx on the other. Would you subtract cosine or would you add the 4 sine? I like positives, so I would add the 4 sine to both sides. And what does that give me now? It gives me cosine of x equals 4 sine of 2y times dy dx. What's the opposite of multiplying if I want to get dy dx by itself? I would divide. So when I divide, I'd get cosine of x divided by what now? 4 sine of 2y. And that would be dy dx for 11. Okay, I think I was also asked number 17, the derivative of these term by term. So power, base, 1 less power, derivative of base. Because it's a y, you put dy dx. Now I keep the minus 3 out front, and I want to do the derivative of ln of y. The derivative of ln of y, if the derivative of ln of u is 1 over u times u prime. So the derivative of natural log of y would be 1 over y times y prime, or 1 over y times dy dx. So that's what's going to go in here. 1 over y dy dx. That becomes 1 over u times u prime, because that's the derivative for natural logs, or the rule for the derivative of the natural log. Power, base, 1 less power, derivative of base. Because it's a y, you put dy dx. Derivative of a constant like 10 is 0. So this is minus 3 over y dy dx plus 2y dy dx equals 0. Are there any terms that do not contain a dy dx? No. So I'm going to factor dy dx out of all three of these. Thank you. Leaving 2y minus 3 over y. Are they both y squared? No. That doesn't make sense, because they would not write it that way. Okay, this was written down wrong initially. This should not be a y squared. This should be an x squared. How does that affect the derivative? It actually makes it a little simpler. 2x power base, 1 less power, derivative of base. So really it's just a 2x. Now they don't all contain dy dx, do they? No. So which one do you want to move? The ones with dy dx or the 2x? Okay, if I move the 2x to the other side, it'd be a negative 2x, right? Can you factor dy dx out of these two right here? If you take it out, would you have 2y minus 3 over y? 2y minus 3 over y. Finally, you want to divide, right? So you have negative 2x divided by 2y minus 3 over y. I won't accept a fraction in a fraction, so opposite dividing by y would be to multiply by y, but I have to use a fancy form of 1. So what do I get here? I think I end up with, in the numerator, negative 2xy, and in the denominator, 2y squared minus 3, because the y's would cancel. I think 23 is the next biggest. They want us to do it implicit and explicit to show that they're the same. And I think I might even graph this, because I think it's a good idea for you guys to know graphs. So I recognize this right away. I would hope you would too. X minus 0 squared plus y minus 0 squared equals 8 squared. X minus h squared plus y minus k quantity squared equals r squared. This tells me that this is a circle centered at the origin, 0, 0, with a radius of 8. So I make my graph. Now that's conic sections, circles. It doesn't get easier. There's parabolas, ellipses, and hyperbolas. This is the form for a circle. I know we did it last year in pre-calc. I know you do it in Algebra 2. So I'm hoping the conics on the third time around might make a little more sense. Now when you hit it in Calculus 2, you're really going to have to know your conics. So it becomes very important. Now I can tell you on this one, both variables are squared and added with the same coefficients. That tells me it's a circle. On this one, I have both variables squared subtracted. That tells me it's an ellipse, because you have different coefficients, 16 and 1. But we're back on this one. Part of it wants us to graph, so I graphed it. Let me get rid of all this. Could anybody solve this for y? Y squared would equal 64 minus x squared. So what would y equal? Plus or minus square root of 64 minus x squared. Are you aware that the top part is the positive square root part and the bottom part is the negative square root part? That's why it's plus or minus. So I'm going to do it implicitly, explicitly, and show that they're the same. First off, I'm going to take the derivative here. Power base, 1 less power, derivative of base. Because it's an x, I put dx dx. Power base, 1 less power, derivative of base. Because it's a y, I put dy dx. The derivative of a constant like 64 is 0. I would subtract 2x, and then I would divide by 2y, and I would have dy dx equaling negative x over y, just like we did in question number 1 on the assignment, and the practice when I introduced the topic. It was just pointed out that pretty much any circle, its derivative is going to be negative x over y, and I think I agree with that. Now I got the graph, so I'm going to take it away. Are you aware that this means to the 1/2 power? So when I take this derivative explicitly, which just simply means solve for y, you would do power 1/2 times the base, 64 minus x squared, to the 1 less power times the derivative of the base, which is, let's go ahead and write it out. What's the derivative of 64? 0. Power base, 1 less power, derivative of base. Really, it's just a negative 2x. 1/2 times the negative 2x could cancel or make it a 1, making dy dx negative x over the square root of 64 minus x squared. Now I've done the derivative implicitly on the left. I've done it explicitly on the right. And can I show them as equivalent? What is the square root? Could that be called y? So are these the same? The answer should be yes. It was pointed out, rightfully so, that I really only did the derivative of the positive square root. And that's fine. I just wanted you to show equivalence. Okay, after 23, I was asked 25. Both variables squared, subtracted. Oh, I'm sorry, this is not an ellipse. This is a hyperbola. Both variables squared, added, same coefficient as a circle. Both variables squared, added with different coefficients as an ellipse. Only one variable squared is a parabola, but if both variables are squared and subtracted like we have here, this is a hyperbola. So let's see how you can do with graphing a hyperbola. I would have to make this equal 1. How would you do that? I would divide every term by 16. That makes it into y squared over 1 minus x squared over 16 equals 1. In general, y could be y minus 0. X could be x minus 0. And let's see. The form in general is, in this case, y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. Do you agree that h and k are 0, 0? So it's centered at 0, 0. How far, what is under the y? A 1. What's the square root of 1? That means I go 1 in the y direction. So 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. Anyway, I go 1 in the y direction. So 1 up, 1 down. What's under the x? So what's its square root? 4. That means I go 4 in the x direction. 4 to the left, 4 to the right. If it was an ellipse, if it was a plus, I would just sketch an ellipse. But because it's a minus, it's actually a hyperbola. A hyperbola, you have to make a dotted rectangle given those parameters. Draw the diagonals, also dotted. Those will become asymptotes. Now I need to know which is positive, the x or the y. The y, which means that it opens like the y-axis does. So your actual graph is going to be here and approach this asymptote and this asymptote, and then this asymptote and this asymptote. So there's my graph. That's just a sketch of this hyperbola. I haven't done implicit or explicit. I'll do that in a moment. If it's okay, I'm going to erase this so I can do the implicit and explicit. Okay, seems like everybody's got it, so I might do an erase. Okay, I erased all that. Now I'm going to do this explicitly. Implicitly first. Keep the 16 out as a constant factor. Power, base, 1 less power, derivative of base. Because the base is y, its derivative is dy dx. So I have this. Minus the derivative of x squared is power base, 1 less power, derivative of base. Since it's an x, is dx dx. The derivative of a constant like 16 is 0. I would add the 2x over and divide by 32y. So I'm adding the 2x over. I'm going to divide by 32y. And what does that make dy dx? X over 16y. X over 16y.
Why can't you just let the computers handle this?
Now that is explicit. I apologize, that's not explicit. That's when it's not solved for y. This is not solved for y. This is called implicit. Explicit will be when it is explicitly solved for y. In other words, it has to say y equals. Okay, for explicit, we have to have it solved for y. So how would I solve this thing for y? I think I would add the x squared over first, right? Would that make it into 16 plus x squared? Then I would divide by 16, which would give me this over 16. Then I would take the square root of the top, which I can't do anything with, and the square root of the bottom, which is 4. So I'm going to call this 1/4 16 plus x squared to the 1/2. Now I'm going to find its derivative. I haven't done anything but manipulate it so far. Okay. The 1/4 comes from right here. Now, I'm going to keep the 1/4 out front, do the power times the base to the 1 less power times the derivative of the base, which is 2x dx dx. So I have 1/8. Actually, I have a 2x on top, don't I? Do you agree there'd be a 2x on top? 2x on top. 2 times 4 is 8 on the bottom, and that's a square root on the bottom, right? Does 2 over 8 simplify? Yes. I'm going to finish this problem if you don't mind. X over, what would that be? 4 radical, 16 plus x squared. If y is 1/4 of the radical, would 4y be the radical? Or would 4 times a radical equal 16y is what I'm trying to ask? Yes. If I take 16 times both sides, I'd have 16y equals 4 times a radical, showing that these two are equivalent.